Hello everyone, here I am, Edla Ajay Kumar, studying in ECEC section. My roll number is 24BQ1A04I8. Today, here I am to explain about the seminar topic total probability theorem. In the total probability theorem, I have to explain about the contents like introduction, definition, and its explanation about any events and its examples and applications of our real applications which we used in our daily life. Mainly, the first content of my seminar topic is about introduction. In introduction, the total probability theorem, it is also known as law of total probability. It is used to find the probability of an one event considering that the probabilities of all the events. The theorem of total probability helps us in finding the probability of an event by considering different cases or partitions of the sample space. Let us consider a sample space S. Now the total probability theorem helps us to find the considering of one event. It is helps us to find the probability of finding the one event probability considering that another event has happened n times. Next, the definition of the definition of the total probability theorem is let us consider that the event B has happened n times in a sample space S, like that event B1, B2, B3, and so on Bn. Now we have to find the Now we have to consider another event A. This is also related to sample space S. Now we have to find the probability of event A considering that B1, B2, Bn and so on, B1, B2, B3, so on, Bn has happened. So now the total probability theorem formula is about finding the probability of A in the sample space. So now let us try to find the probability of A using total probability theorem. The formula for finding probability of A is P of B1 into P of A by B1 plus P of B2 into P of A by B2 plus and so on P of Bn into P of A by Bn. Here, P of A is about the probability of an event A happening in the sample space S. Next, P of B1, B2, B3, so on Bn is the probability of event B occurring n times. That is also in sample space. Next, this is the main condition. Here, P of A by B equal to is called conditional probability. The conditional probability is about here we have to find the probability of event A. This is simple, but we have to find the probability of A considering that B happened. Let us consider. Let us consider an example for this conditional probability. Let us consider a example for this conditional probability, like that a person has gotten sick. If he could get a positive test or negative test, like that we use conditional probability. Like in that cases, we use conditional probability. Next, explanation about the total probability theorem. First, consider a sample space S. Next, divide that sample space into n mutually exclusive and exhaustive events. Let us consider Consider the event B is into n different events. Use conditional probability for each partition, like that P of B1, P of B2, P of B3, like that. Consider n partitions and do the conditional probability for event A given that B1, B2, B3, so on Bn is happened. Then multiply the each conditional probability, like that P of A by B1, P of A by B2, P of A by B3, P of A by Bn, and so on P of A by Bn, like that for conditional probability. Then totally multiply the all the events. Let us consider an example for proving the proving the total probability theorem. Here, suppose a factory has three machines A, B, and C producing bulbs. Let us consider a factory has three machines A and B and C producing bulbs. First, A produces 30% of the bulbs of the total bulbs produced by a total machines produced by a factory. B produces 50% and C produces 20%. In that bulbs, there are some defective bulbs, like in the total machines created by a total machines produced by a total bulbs produced by a factory. In that machine A produces 30% of the bulbs. Machine B produces 50% of the bulbs. Machine C produces 20% of the bulbs. Probability of a defective bulb from each of the machines. machine A produces 0.01 percentage of its 30% bulbs. Next, machine B produces 0.03 of its 50% bulbs. Machine C produces 20% of its 20% of the bulbs in a factory. Next, now we have to find the probability that a randomly chosen bulb is defective. Here the problem is asking about defective bulb not from the machines. This is about the defective bulb from machines. Here it is about the defective bulb which is produced by a factory. So we have to do the problem based on the three machines. We have not known about which machine is producing defective bulbs. So now the now we have to use the total probability theorem to find the probability of defective bulbs. Here P of D equal, now based on the general formula of the total probability theorem, we know that P of A equal to P of A by B1 into P of B1 plus P of A by B2 into P of B2, like that P of A by Bn into P of Bn. Here now we have only three conditions. It is 0.3. It is that P of A, like that P of A and P of A means 30% bulbs produced by a factory. That is about 0.3. Here 0.01 means the probability of a defective bulb which is from A. Like that 0.5 is the machines produced by B, 0.03 is defective bulbs produced by machine B, 0.02 is machines bulbs produced by machine B, 0.02 is defective bulbs produced by machine B. So now we have to multiply the each conditions for machine A, machine B, machine C. 0.03 into 0.01 is about machine A bulbs and its defective bulbs. 0.05 into 0.3, 0.03 is about machines produced by bulbs produced by machine B and defective bulbs produced by machine B. 0.02 into 0.02 is about bulbs produced by machine C and defective bulbs produced by machine C. Now we have to do the products of each individual machines, and then we have to do summation on the three machines bulbs to get a defective bulb which comes out from that factory. Here in these cases, when there are n mutually exclusive and exhaustive events, we would use total probability theorem for finding that. Now we have to do some real life applications based on the total probability theorem. Here the total probability theorem applications are risk analysis. When the problems are complex, like that, when there are n number of events, like n equal to 100,000, like very much big number, we have not to do simple mathematical calculations to find the probability of single event in the 1,000 events. Then we would go for total probability theorem. Next, some of the examples are some engineering related operations are reliability engineering and machine learning engineering. In that machine learning, there is one of the key important application is Bayesian models. Then we have to use the total probability theorem for decision making under uncertainty. When we are not known about the total conditions of the problems, we would go for total probability theorem. It is also used in some medical diagnosis, like finding the probability of sick persons, unsick persons, like that. Next, we would go for conclusion of our seminar topic. Mainly the key topics of the total probability theorem is this total probability theorem is a fundamental tool in probability theory. It allows us to compute probabilities by considering all possible cases. In this total probability theorem, we would use all the events P of B1, P of B2, and that's total sample space. We use all the events. Next, this total probability theorem is closely related to Bayes theorem to calculate reverse probability of an event. Mainly the Bayes theorem and total probability theorem is so much related. In Bayes theorem, for suppose we know that the formula of Bayes theorem is P of A by Bn equal to P of Bn by A into P of. We know that the total probability theorem is closely related to Bayes theorem. We know the Bayes theorem formula. Bayes theorem formula is P of A by Bn equal to P of Bn by A into P of A by P of Bn. Here P of A is about the probability of event A when we are finding in total probability theorem. For when we are using Bayes theorem for a problems, we have to do the conditional probability and total probability theorem. Mainly the total probability theorem, Bayes theorem, and the conditional probability theorem is mostly interlinked in PDSP. So we have to find the when we are using probability theorem, the conditional probability is must essential to find the total probability theorem, because we have to find the total probability theorem by using conditional probability theorem. When we are using Bayes theorem, the total probability theorem and conditional probability theorem both are essential to find that. Thank you for giving me this opportunity to tell the similar topic about total probability theorem.